Problem number 13. So this one is our practicing making sure we can find equations of tangent lines. It gives us 4 different functions, and we need to write out what their tangent lines are at some given value of a. And to make it as mean as possible, I've only given you the x value, not the y. So let's go ahead and work this out. So a, I've got 2x squared plus 3x minus 4 when a is equal to 3. And what I need to do is find equation of a tangent line. So to do that, I need to take a derivative. So f prime of x is 4x plus 3. And remember, that's what that means. F prime of x gives you the slope of the tangent line at any given point. So let's go ahead and use that. So m equals f prime of 3 equals 4 times 3 plus 3 is 15. I also need to know what point I'm at, so I need to plug in f of 3. F of 3 is 2 times 3 squared plus 3 times 3 minus 4. So that's 2 times 9 is 18, plus another 9 is 27, minus 4 is 23. So my point of interest is 3, 23. So I have y equals mx plus b. I can plug in. You can use point slope form if you want. 15 times 3 plus b. 15 times 3 is 45. So subtract that. I get minus 22 equals b. So y equals 15x minus 22. And that's the equation of my tangent line. This is also good practice for taking derivatives. So if I'm asking you to find the equation of a tangent line, I'm not expecting you to do it by the definition. The only time I want you to do it that way is if I specifically say. I didn't know that moved. So next here I finally tried to concede a little bit and do functions that weren't f of x. So g of y is y sine y. So we need to find the derivative here. So let's do that. First let's find the point. Really I should do that first because it makes things less weird. So g of 0 is equal to 0. Both y and sine of y are equal to 0. So that's my origin point. G prime of y, we have to use the product rule for. Again, if you take a derivative that needs a product rule and you don't use the product rule, that's big points off. So first times derivative of the second is y times cosine of y, plus derivative of the first times the second is sine of y. So g prime of 0 is equal to 0. So we have something kind of interesting happening. Here, if I even made an attempt to plug in y equals mx plus b, I get 0 equals 0 times 0 plus b, implies b is equal to 0. So my equation is just y equals 0. No matter what I plug in, I get 0. So it has a horizontal tangent line, which is kind of fun. Okay. Part C. This is another one I need to fix. So let me make a note of the ones I need to fix. Not exactly the most professional time to be doing this, but that's okay. So that x that I splayed up first shouldn't be there. And while I'm at it, what was the other one I messed up? There was another one I needed to fix, but I don't remember what it was now. But okay. So the function should be t plus 1 over t minus 2. And our a is equal to 1. Okay, great. So I have a quotient. So that's signaling to me I need to use quotient rule. And this is what, h of t? So the numerator is t plus 1. The denominator is t minus 2. N prime is just 1. D prime is just 1. Nothing too crazy at all going on. So I have h prime of t is low d high. So n of t, no, d of t times 1 minus n of t times 1 plus 1 times 1 over the bottom squared equals t minus 2 minus t minus 1, distributing the negative, equals minus 3 over t minus 2 squared. So that's our derivative. Now we need the slope of the tangent line. So m equals h prime of 1 equals minus 3 over 1 minus 2 squared equals minus 3. Also, h of 1 is 2 over minus 1 equals minus 2, so my point is 1 comma minus 2. So I can put everything together. Y equals mx plus b. Y was equal to, I already forgot, minus 2 equals minus 3 times 1 plus b minus 2. Add in the 3 on both sides. I get 1 equals b. So the equation of my tangent line is y equals minus 3x plus 1. And that works out nicely. Okay, great. So one last one to find. J of x is equal to square root x squared plus 5. A equals 2. I'm going to find the point immediately this time. So the x value it gave me was 2. If I plug in, I get square root of 4 plus 5, which is 3.23. Great. I have that. Now let's find the derivative. J prime of x is, by the chain rule, I get 1 over square root x squared plus 5 times the derivative of the inside function, which is x squared plus 5, equals 1. Actually, let me get rid of that. So I get 2x over square root x squared plus 5. Now I want to plug in 2. So m equals j prime of 2 equals 2 times 2 over square root of 9 equals 4/3. Again, one last time, find the equation of the tangent line. So 3 is equal to 4/3 times 2 plus b. So that's 8/3. 3 is 9/3. If you do the subtraction, you get 1/3 is equal to b. So y is equal to 4/3 x plus 1/3. And that's our final answer. And that's top off to 13.